Today we're going to be solving rational equations, part 3. We're going to follow the same steps that we had before. The steps make it easier to solve our problems. Step 1, we're going to make sure our denominators are factored. Step 2, we're going to find our least common denominator, also known as the LCD. Step 3, we're going to find our restrictions. Step 4, we're going to multiply in our least common denominator to the entire equation. Step 5, we're going to solve for x. Let's take a look at example 7. For example 7, I have 10 all divided by 2x plus 8 minus 7x plus 8 all divided by x squared minus 16 equals a negative 8 divided by 2x minus 8. My first step says to factor my denominators. So I'm going to look at this and I'm going to factor my first denominator using my greatest common factor. I'm going to factor my second denominator using difference of squares. And I'm going to factor my third factor using the greatest common factor. I'm going to rewrite my problems. With their factored denominators, I end up with 10 divided by 2 parentheses x plus 4 minus 7x plus 8 all over x plus 4, x minus 4 equals a negative 8 all over 2 parentheses x minus 4. Notice I move that negative sign up to the numerator. You can do that as long as you move it either to the numerator or the denominator. Now I'm going to figure out what my least common denominator is. Remember, your least common denominator must include every factor that's in your denominator. So I have a 2 in my first fraction and I have a 2 in my third fraction. That is the same factor. So I'm going to put a 2 down for my least common denominator. I have an x plus 4 in my first fraction and an x plus 4 in my second fraction. So I must write down an x plus 4 in my least common denominator. I have an x minus 4 in my second fraction and in my third fraction. So I must include an x minus 4 in my least common denominator. Now I'm going to set my restrictions. Remember, restrictions are values that you cannot use as solutions because they make our fractions undefined. To set my restrictions, we set every factor equal to 0 and we solve for x. Well, if I look at my first factor in my denominator, it is a 2. If I were to try to set 2 equal to 0, this is an impossible statement. It's a false statement, so that cannot work. Because that 2 does not have a variable beside it, we do not include it as a restricted value. Then I can do the x plus 4. When I set x plus 4 equal to 0 and solve for x, I can solve for x and I end up getting x is equal to a negative 4. And then if I set my x minus 4 equal to 0 and I solve for x, I can see that I get an x is equal to a positive 4. So I know that x cannot equal a negative 4 or a positive 4. If I were to use these as solutions, I would get undefined fractions in my problem, and I cannot have that. My fourth step says to multiply my least common denominator into my entire equation. So I'm going to multiply my entire equation with the 2, the x plus 4, and the x minus 4. When I multiply it into my first fraction, I end up with 10 times 2 parentheses x plus 4, x minus 4, all over 2 parentheses x plus 4. I have a subtraction sign. I'm going to multiply in my LCD to my second fraction. Now be careful, there was already a binomial above my second fraction, so I'm going to make sure to put that in parentheses. I have 7x plus 8 times 2 parentheses x plus 4, x minus 4, all over x plus 4, x minus 4, equals, I'm going to multiply in my LCD to my third fraction. I end up with a negative 8 times 2 parentheses x plus 4, x minus 4, all over 2 parentheses x minus 4. Now I'm going to look to see what's going to reduce out. I can get rid of my 2's and my x plus 4's of my first fraction. I can get rid of the x plus 4's and the x minus 4's of my second fraction. And I can get rid of the 2's and the x minus 4's of my third fraction. When I do this, I can rewrite my problem so it's a little bit simpler. I end up with a 10 times an x minus 4 minus I end up with a parentheses 7x plus 8 times a 2 is equal to, and then across the equal sign I end up with a negative 8 parentheses and an x plus 4. After the subtraction sign, we end up with a parentheses 7x plus 8 times a 2. We're used to having our 2 in front, so I'm going to actually switch these around and rewrite it so it's a little bit easier, because sometimes whenever it's written like this, it gets a little confusing for some people. So I'm going to rewrite this so I have a 10 parentheses x minus 4 minus 2 parentheses 7x plus 8 equals a negative 8 parentheses x plus 4. Now I'm going to use the distributive property so I can solve for x. So 10 times x gives me a positive 10x. 10 times the negative 4 gives me a negative 40. Negative 2 times 7x gives me a negative 14x. Negative 2 times a positive 8 gives me a negative 16. Equals negative 8 times x gives me a negative 8x. Negative 8 times a positive 4 gives me a negative 32. Now I'm going to go ahead and combine like terms. 10x minus 14x gives me a negative 4x. Negative 40 minus a 16 gives me a negative 56 equals a negative 8x minus a 32. I'm going to solve for x. I can see that these are linear, so I'm going to get my x's on the left side and my numbers on the right side. I'm going to add 8x to move it to the left side. And I'm going to add 56 to move it to the right side. When I do that, negative 4x plus 8x gives me a 4x. My 56 and my negative 56 cancel. Equals my positive 8x and my negative 8x cancel. And then I have negative 32 plus 56. Well, this gives me a positive 24. Now I'm going to divide by 4, and I get x is equal to a 6. So here is my solution. And I can see that my 6 is not a restricted value, so I can use it as a valid solution. Now looking at example 8, I have x plus 1 all divided by x minus 1 is equal to x divided by 3 plus 2 divided by x minus 1. The first step that I need to do is to factor my denominators, but by looking at my denominators, I can see that they are already prime. My second step is to find my least common denominator. My least common denominator must include every factor in my denominators. I have an x minus 1 in my first fraction and an x minus 1 in my third fraction, so I must include x minus 1 in my least common denominator. I have a 3 in my second fraction. I must include my 3 in my least common denominator. You can put the 3 at the end, but that looks a little bit weird. We're used to seeing it the other way, so I'm actually going to switch this around, and I'm going to say that my least common denominator is a 3 and an x minus 1. Because this is more pleasing to the eye, only because this is what we've been used to writing all along. So now I'm going to set my restrictions. Don't forget, for your restrictions, you set every factor in your least common denominator equal to 0 and solve for x. My first factor in my least common denominator is a 3. If I tried to do 3 is equal to 0, I would see that this is a false statement, so this is impossible. Anytime you have a number that does not have a variable beside it as a factor, you're never going to use it because it's impossible, because it's never equal to 0. So I'm going to set my second factor equal to 0 and solve for x. Whenever I do that, I can see x is equal to a positive 1. So I know x cannot equal a positive 1, because if it did, it would give me an undefined fraction. My fourth step says to multiply in the least common denominator to the entire equation. So I'm going to multiply a 3 times an x minus 1 into the entire equation. When I multiply it with my first fraction, since there's already a binomial up there, I'm going to make sure I stick that in parentheses. So I have parentheses x plus 1 times a 3 times an x minus 1 all over x minus 1 equals, I'm going to multiply it into my second fraction. I end up with an x times a 3 parentheses x minus 1 all over 3. I multiply it into my third fraction. I end up with 2 times 3 parentheses x minus 1 all over x minus 1. Then I'm going to look to see what reduces out. For my first fraction, I can get rid of the x minus 1s. For my second fraction, I can get rid of my 3's. And for my third fractions, I can get rid of my x minus 1s. So I have x plus 1 times a 3 is equal to x times an x minus 1 plus my 2 times my 3. I'm going to rewrite this so it's a little more pleasing to the eye. I'm going to rewrite my first part so that my 3's in front. I have 3 times x plus 1 is equal to x times x minus 1. And then plus 2 times 3 I know is 6. So I'm going to replace that with a 6. Now I'm going to use the distributive property so I can simplify some more. 3 times x gives me a positive 3x. 3 times a positive 1 gives me a positive 3 equals x times x gives me a positive x squared. X times a negative 1 gives me a negative x. And I still have my positive 6. Now I can see one of my terms is quadratic. I have an x squared, so I need to make sure that whenever I have an x squared, I get everything on the same side as the x squared, because when solving for quadratics, we have to get our equation equal to 0 so we can see what we can do to solve for x. So I'm going to subtract 3x from both sides. I'm going to subtract 3 from both sides. When I do that, the left side cancels out completely and I get 0 equals x squared. A negative x and a negative 3x give me a negative 4x. And then 6 minus 3 gives me a positive 3. Now I'm going to see what I can do to factor this. Well, it's a trinomial. I know I can use MIFTERM. So my factors are going to be 0 equals parentheses x minus 3, parentheses x minus 1. Once I have my factors, I can set each factor equal to 0 so I can solve for x. If I set x minus 3 equal to 0, and I wanted to solve for x, I would add 3 to both sides, and I would get x is equal to a positive 3. If I wanted to do the x minus 1 equal to 0, I would add 1 to both sides, and I would get x is equal to a positive 1. Well, x is equal to 3 and x is equal to 1 are my solutions. But if I look, my x equals a positive 1 is a restricted value. So x equals 1 is not going to work because it would make my fractions undefined. But x equals a positive 3 would work. So x equals 3 is the only solution that we can actually use. For example 9, we have 7x plus 3 all divided by x squared minus 8x plus 15. Plus 3x divided by x minus 5 is equal to a negative 1 divided by an x minus 3. According to my first step, I need to make sure my denominators are factored. I can see that I can factor my first denominator using MIFTERM. So I'm going to rewrite my problem with its factored denominator. I end up with 7x plus 3 all over x minus 5 times x minus 3 plus I have my 3x all over my x minus 5 is equal to my negative 1 all over my x minus 3. My second step says to write my least common denominator. My least common denominator must include every factor in my denominator. So I have an x minus 5 in my first fraction and I have an x minus 5 in my second fraction. I must include x minus 5 in my least common denominator. I have an x minus 3 in my first fraction and I have an x minus 3 in my third fraction, so I must also include my x minus 3 in my least common denominator. Once I find my least common denominator, my third step says to find my restrictions. My restricted values are whenever I set my factors in my least common denominator equal to 0 and solve for x. If I set x minus 5 equal to 0 to solve for x, I would get x is equal to a positive 5. Then, if I did x minus 3 equal to 0 and I solve for x, I would get x is equal to a positive 3. I know that these are restricted values, so x cannot equal 5. It cannot equal a positive 3 because if it did, when we plugged it back into our original problem, we would get fractions that are undefined. Step 4 says to multiply in your least common denominator to your entire equation. My least common denominator is an x minus 5 and an x minus 3. When I multiply it into my first fraction. Since I already have a binomial in the numerator of my first fraction, I need to make sure I go ahead and include parentheses around that 7x plus 3. So I would rewrite this as parentheses 7x plus 3 times an x minus 5 times an x minus 3 all over x minus 5, x minus 3. Plus, I'm going to multiply in my least common denominator to my second fraction. I end up with 3x parentheses x minus 5, x minus 3 all over x minus 5 is equal to, when I multiply it into my third fraction, I end up with a negative 1 times an x minus 5 and an x minus 3 all over my x minus 3. Now I'm going to see what reduces out. In my first fraction, I can get rid of my x minus 5 and my x minus 3. In my second fraction, I can get rid of the x minus 5. And in my third fraction, I can get rid of the x minus 3. I'm going to rewrite this in its simpler form so I can see what I have left. I have 7x plus 3 plus 3x parentheses x minus 3 is equal to a negative 1 parentheses x minus 5. Now I'm going to go ahead and use the distributive property so I can simplify this some more. I have 7x plus 3. When I multiply 3x times x, I get a positive 3x squared. 3x times a negative 3 gives me a negative 9x is equal to negative 1 times x gives me a negative 1x. A negative 1 times a negative 5 gives me a positive 5. Now I'm going to go ahead and combine like terms, and I'm going to write it in descending order. I have a positive 3x squared. A positive 7x and a negative 9x give me a negative 2x. I have a positive 3, so I'm going to put plus 3 is equal to a negative 1x plus 5. I'm going to go ahead and get everything on the same side as that x squared. So I'm going to add 1x to the left side. I'm going to add 1x to the right side. I'm going to subtract 5 from my right side, and I'm going to subtract 5 from my left side. Whenever I simplify this, I end up with 3x squared minus x minus 2 is equal to 0 because everything cancels on the right side. Now, I can see that I have a quadratic, and it's 3 terms, so it's a trinomial. I can factor this using MIFTER. I'm going to go ahead and refresh your memory on how to factor it when we have a leading coefficient. I'm going to multiply my leading coefficient and my last term. I get a negative 6. I need two numbers that will multiply to give me a negative 6, but will subtract to give me this negative 1. So I'm going to use a negative 3 and a positive 2. Negative 3 times 2 gives me the negative 6. Negative 3 plus 2 gives me the negative 1. I'm going to divide by my leading coefficient of 3. And whenever I do that, I get a reduced fraction of negative 1 over 1 and 2 over 3. I put my x's in my denominators, and I can rewrite my factors as x minus 1 and 3x plus 2. And these are both equal to 0. To find the solutions of my problem, I'm going to set each factor equal to 0. For x minus 1 equal to 0, I can solve for x. I'm going to add 1 to both sides. I get x is equal to a positive 1. And then whenever I have 3x plus 2 is equal to 0, I'm going to subtract 2 from both sides. I get 3x is equal to a negative 2. I'm going to divide by 3, and I get x is equal to a negative 2/3. X equals a positive 1 and x equals a negative 2/3. Neither one of these are restricted values, so I can use both of these as valid solutions.